Friends, very good morning. Today I have a question to you. What type of reactions benzene can undergo? Definitely, it's a substitution reaction. And which type of substitution? As benzene is aromatic, electron rich species, it can undergo electrophilic substitution. But however, we can carry out nucleophilic substitutions under special conditions. The special condition one can be if it has strongly electron withdrawing groups on it. Then, to certain extent, nucleophilic substitution can be possible. What this electron withdrawing groups does, as the name indicates, withdraws the electrons from the benzene and make it electron deficient, so that nucleophile, which is electron rich, can attack. Today's subject of discussion is a nucleophilic substitution reaction of the benzene ring system. It's nothing but Smiles rearrangement. Smiles rearrangement is intramolecular nucleophilic aromatic substitution. It occurs within the molecule, no external reagent required as a source of nucleophile. And here, the nucleophile within the molecule gets substitutes onto the benzene ring system. This occurs in benzene ring system to which a nucleophile containing group is attached through a heteroatom. The arene compounds with X is equal to sulfur oxide or sulfur or oxygen, or it can be any substituent which is capable of dislodging from the arene carrying the negative charge. Here, the Y over here is a strong nucleophile. It can be an alcohol or an amine or a thiol. How this rearrangement occurs? Let us look into it. I take the arene compound which is having a substituent capable of dislodging from arene carrying electrons with it. Means it should be electronegative in nature. I treat with a strong base like sodium ethoxide. Sodium ethoxide, how will you prepare? Take absolute ethanol and add sodium into it. We get sodium ethoxide. Sodium ethoxide is a stronger base than that of sodium hydroxide. We need a strong base like sodium ethoxide. This can dissociate into Na plus and OET minus. As this OET minus is electron rich, it is sufficiently basic enough to get a proton, and here to the nitrogen, the hydrogen is attached, and adjacent to it there is an electron withdrawing group. Because of this electron withdrawing group carbonyl, it pulls the electrons from the nitrogen, and the bond between nitrogen and hydrogen is weak and is acidic enough to lose a proton. The ethoxide ion OET minus abstract the proton, and this proton moves away, leaving the electron pairs onto the nitrogen. The nitrogen become electron rich. Once it is rich, it is unstable. To maintain its stability, the excess electron which it has gained, that becomes electron rich, which we represent as minus, and this attacks on the benzene ring system. Once it attacks, it has to maintain its tetravalency. Hence, pi electrons moves onto the adjacent carbon, creating a carbene ion. We get a cyclized intermediate of this sort. And here carbon ion which is formed is unstable. It has to regain its stability. That's why it gives back its electron to this adjacent carbon from which it has got. These electrons are given to this carbon and this is given back. It is not taking. That's why what happens? It breaks up the carbon oxygen bond over here. This electrons moves onto oxygen and this becomes O minus. O minus combines with H plus of ethanol. What we added? Sodium ethoxide. We have prepared by adding sodium into ethanol. The ethanol H, it combines and it becomes OH. And the nitrogen, which is electron rich and nucleophile, has got attached to the benzene ring system. That's why it is nucleophilic aromatic substitution. It occurs within the molecule. That's why it is intramolecular nucleophilic aromatic substitution. This has been given by Smiles and hence it is named after him as Smiles rearrangement. For this reaction to occur, it should have a strong electron withdrawing group on the benzene ring system. It abstract the electrons from the benzene ring system and make it electron deficient such that a nucleophile can come and attack. The preliminary requirement for this Miles rearrangement to occur is that it should have strong electron withdrawing group like nitro, preferably either at ortho or para position, and it's a must for reactivity, and without that this reaction do not occur. This is the salient feature of this reaction and also the limitation of this reaction. Next class we can deal with other rearrangements. Till then, have a nice day. Thank you.